What I want to make sure to highlight as we move on to this next problem is just because molecules get bigger, just because molecules get more complex, we're going to still keep applying the same basic rules. And this is a theme that we've been doing since we started doing problems in Chapter 1 with unit conversions. Just because things get more complex, just keep applying the same types of methodologies and you should be able to work yourself through problems. This next problem asks us to draw a Lewis structure for the molecule methanol, an important industrial alcohol, again, that can be used as a gasoline additive. So the molecular formula is given here. So from the molecular formula, we can figure out, again, our glue. So the glue that we have here, and again, going more quickly, if you find that I'm going too quickly as I'm drawing Lewis structures here, go back and look at sample problem 10.1, because I will continue to take more and more liberties with drawing Lewis structures with the assumption that people are proficient at them. All right, so we've got one carbon atom, 4 hydrogen atoms, and 1 oxygen atom. So we've got 4 electrons from our carbon atom. Each hydrogen has 1 electron, so with 4 of them that makes a total of 4 electrons and 6 electrons from our oxygen. So we've got 14 electrons total that we have to put in our molecule. Looking at the fact that we've got carbon and hydrogen atoms, we know that carbon and oxygen are likely to be central atoms because they not only are not as electronegative, but hydrogen, in only forming a single bond with species, has to be a peripheral species. So if I kind of start spacing things, I'm going to space my hydrogens around here, and I'm going to put another hydrogen there. I'm going to connect everything with single bonds. 2, 4, 6, 8, 10 electrons. I've got 4 remaining, and they're going to go on oxygen here to complete its octet. Now I kind of went through this fairly quickly, but one of the things you'll realize is there's actually no other ways that we can piece these pieces together and have things that are not expanding their octets, deficient of octets, and so forth. So again, looking at this, there are 2 central atoms, but one of the things that I want to kind of highlight and point out as we start working through these problems is start looking at trends for how atoms like to bond, and particularly trends as they relate to where they are in the periodic table. So again, looking at things from group 4A, 5A, 6A, and 7A. And I'm going to take things that are from period 2 in the periodic table, which means I'm going to be talking about carbon, nitrogen, oxygen, and fluorine. Now, if we think about what carbon likes to do, carbon likes to have 4 bonds. And the reason is this, is when there's 4 bonds to carbon, if we talk about how many electrons it owns and how many it wants, it owns 4 electrons in having 4 bonds. It wants 4 electrons based on its valence, so the formal charge is going to be 0 when we have carbon having 4 bonds. Any other combination of that is going to give a formal charge that's not 0, and that's not desirable. So see if we can follow the trend that we're going to see here. Nitrogen likes to have 3 bonds and 1 lone pair, because that gives it 5 electrons that it owns, which is the 5 that it wants, for a 0 formal charge. Oxygen likes to bond twice with 2 lone pairs, because that gives it 6 electrons to own, which is the same as what it wants, for a 0 formal charge. We also can have oxygen binding like this, with 2 bonds and 2 lone pairs. Halogens, which we'll just abbreviate as an X, like to have 1 bond and 3 lone pairs. Again, the reasoning is that gives it 7 electrons that it owns, 7 that it wants to own, and a formal charge of 0. The more you start to recognize these bonding patterns early, the easier drawing Lewis structures will become, and the more likely you'll be able to identify when you've made a mistake in drawing a Lewis structure. Okay, so this problem was pretty straightforward. Again, don't worry if you have molecules that are a little bit bigger, have more than 1 central atom. Just understand that there are going to be unique ways that we can piece these together. And again, even though we have two central atoms, the rest of the atoms are what we'd call peripheral atoms. Hydrogen's always going to be on the end because it can only bond once, having only 2 electrons to contribute to a duet rule.